Hi, today I'm going to take you through the formulas for finance that appear in the QCAA General Maths formula sheet. I'm going to split this into two videos. The first one will focus on simple and compound interest as well as comparing interest rates. The second video is going to focus on annuities and in particular will show you when to use each of the annuity formulas that are on the sheet. Okay, so let's just start by identifying the formulas that we're looking at here. We've got the simple interest formula that you've probably been using since you were in grade 9. It's quite simple, I equals PIN. So when you'll need that, they'll have in the question, they'll either use the term simple interest or they might use the term flat rate as well. That's another clue that it would be a simple interest question. There is a couple other instances when you can use that simple interest formula, and I'll go through those in a minute. But another thing to remember when you're doing simple interest is that you need to remember the formula that A equals P plus I. In other words, the final amount is equal to the original principal plus the interest. Now that one, obviously it's not on the sheet, so you just need to keep that one in mind. Now compound interest, we've got two formulas here that we can choose from on the formula sheet. One's the original formula you would have learnt in grade 9 and 10. What you need to remember with that, if you're looking at questions, they'll give you a clue that the interest is compounded. They'll talk about a compounding period. It could be monthly, quarterly, daily, for example, and that's going to affect your I and your N that you put into your formula. Another clue that it's compound interest is they might say that the interest is like paid monthly, for example. Now the difference between these two formulas, when we're just looking at the overall situation, the whole term of the investment or loan, depending on what your situation is, we'll be using this formula. But when we're breaking it down into just individual periods, like maybe taking a close look at what's happening in the first couple of months, for example, that's when you would be looking at the recurrence formula. Now, the other formula that I'll cover in this video is the one for comparing interest rates, and that's our effective rate there. So, for example, if you're given a couple of different options for an investment, might be two different compound interest rates that have different compounding periods, then by looking at the effective interest rate, you're enables you to compare and see which one's better. So what you would want to keep in mind is that if it's an investment, you want the highest rate. The highest is the best. And then if it's a loan, the lowest is the best. So keep that in mind for a question involving comparison of rates. Okay, so now let's have a look. I've got some examples ready to go. So here's an example of a simple interest question. We've got a loan of $3,400 taken out over 3 years. Interest is charged at a flat rate, 4.9% per annum. What monthly repayment will be required? So what we've got to be careful of here, they're talking about monthly repayments, so you don't want to immediately think of it as an annuity or like a reducing balance loan, because they've used the term flat rate of 4.9%. That's our clue that it's just a simple interest question. So we've got a couple of steps to finding this. So let's make a note of what we've got first. Our P, principal, is 3,400. We've got an interest rate of 4.9% per annum, and our N, it's taken out for 3 years. So if we go into our compound interest formula, that will tell us how much interest is going to be charged on this loan. So just putting those bits in, just remembering that our interest rate has to go in as a decimal. And that's going to come to $499.80. Now, we need to know the total amount that has to be repaid. So we would add that to our original principal using that formula I mentioned before. So $3,400 plus $499.80, that gives us $3,899.80. Now, if we're going to make monthly repayments to pay this back, we want to know how many payments we're going to have altogether. So first of all, the number of payments is going to just be 3 lots of 12, so 36. So our monthly repayment is then just going to be that total amount divided by 36. So $3,899.80 divided by 36, and that will give us $108.33. Okay, now another situation where we can use the simple interest formula is when we're looking at a perpetuity or an interest-only loan. So these are very similar things, it's just that one is an investment and one is a loan. The key thing that they have in common, though, is that the payment is equal to the interest. So, for example, in a perpetuity, what that means, you've got a lump sum that you're investing. It earns interest and will be paid monthly. And whatever the interest is earned in that month, you'll take that out as a payment so that your investment actually doesn't increase or decrease. It just stays the same over the whole term, however long you have it in that investment. So now if we want to work out here, we've got this investment of $120,000 invested at 3.4% per annum, what monthly payment will be received. All we have to do, we can use the simple interest formula, put $120,000 in as our principal, multiply by the interest rate, which once again we have to put as a decimal. Now our N, we've only got 1 month, 1 period that we're working it out. So our interest rate is annual, so N should be years, so it'll be 1/12 of a year. When we calculate that, that comes out to $340. So that basically means you're going to get a payment of $340 every month for however long you have this $120,000 invested. And it won't go up in value, won't go down in value. At the end of every month, it's still worth $120,000. So likewise with an interest-only loan, it's a very similar situation where in this case you've taken out a loan of $450,000, it might be to buy a house or whatever. Interest is charged at 6.1% per annum, and your monthly repayment is going to be equivalent to the interest that's charged. So all we have to do, we can use that compound interest formula, the simple interest formula again. We're just putting the principal in, 450,000 times the interest rate as a decimal. And once again, it's just 1 month that we're looking at. So 1/12 is our time period. When we calculate that, we get $2,287.50. So that would be the repayment that you'd make every month. Your loan balance is not going to reduce, not going to go up. It's going to stay at the $450,000 indefinitely. Now, let's have a look at some compound interest questions. This time we're going to get a chance to see when we're going to use our standard formula and when we're going to use the recurrence formula. So I've got the same scenario in each case here. We've got a principal of $2,000. So I might make a note of all that over here. Our P is 2,000. Our I, we've got 3.5%, but notice they've used the term compounded monthly. So that's our clue that it's compound interest. So 3.5% per annum. So, but it's compounded monthly. So what we're going to be putting in the formula is 0.035, and we have to put it over 12 to get it down to a monthly interest. Then our N has to be months as well. The interest and the N have to match each other in terms of the compounding period. So 4 years, what we'll be putting in will be 4 times 12 to get 48 months. So simply starting with our formula like that, we've got 2,000, 1 plus 0.035 over 12 to the 48. When we pop that in the calculator, that comes out to $2,300.08. Okay, so notice with that question, we were looking at the big picture. We just wanted to know over the whole life of that investment, what did it end up being? So that's really why we were using this original formula. Whereas now, in this second question, we've got the same compound interest scenario, but now they're asking us how much interest was earned in the third month. So we're coming down and scrutinizing just a little part of that time. So that's where the recurrence formula comes in handy. So here, what we want to remember is that our R is equal to 1 plus I, where I is basically the same I that we've used up here. So 1 plus 0.035 over 12. Now if we put that in the calculator, that comes out to 1.00291, and it's basically 6 recurring after that. So you want to try and keep as much detail as you can with that number while you're doing your calculations. And what we also need to know for our recurrence formula is what our starting point is. So our A0 is our original principal. So our A1, putting that in, it's basically telling us that the next term is equal to R times the previous term. So we've got 1.002916 recurring times 2,000 is giving us what the investment is worth after 1 month. So that comes out to $2,005.83. So this does get a little bit tedious because you have to keep repeating that process. That's why it is a recursive formula. It's the idea of it. So now to get the balance at the end of the second month, I have to multiply that by the balance at the first month. So pop that in. When we put that in the calculator, we get $2,011.68. If I did the same thing with my A3, putting the same thing in, I'm going to get $2,017.55. So now if I want to know how much interest was earned in the third month, I just have to compare at the end of the third and the second month and basically subtract those. So I'm just going A3 minus A2. So 2017.55 minus the 2011.68, and that comes out to $5.87. There you go. That's the difference between those two formulas. Now let's have a look at where we're going to use the comparing interest rates formula, the effective annual rate of interest. So if we've got a question like this where we have two banks offering different investment options and we want to know which one is going to earn the most interest. So basically, all we need to know is that rate and the compounding period. It doesn't matter how much we're investing. We don't need to know that to compare. So all we want to do, we're going to look at each one in turn. So Bank A, their rate, I, is 3.45% per annum, but compounded monthly. So that means our N in the formula is going to be 12. So now if we put that in, I effective is going to be 1 plus 0.0345 over 12 to the power of 12 minus 1, and that comes out to 0.0350579, etc. Now, we're going to round it off a little bit, but you want to be careful to keep a bit of detail there because you need to have enough decimal places that enables you to compare between the two options and see which one's better. So this is like an equivalent rate now that if it was only compounded annually, you would earn the same amount of interest as this 3.45% compounded monthly. So now doing the same thing for Bank B, where their I was 3.4%, but it's daily compounding now. So that means our N is 365. So putting into the formula I effective, we're going to have 1 plus 0.034, putting out interest rate as a decimal, over 365 to the power of 365 and minus 1. Now when we pop all that in the calculator, we would get 0.0345829, etc., which I'll just round off to 3.458%. Now that's less than the 3.505%. So this time, since we are investing, we want the highest interest rate. This one's better. So we would say, therefore, Bank A will earn the most interest. So like I mentioned before, just keep in mind if you're comparing rates, if it was a loan situation, you'd be looking for the smallest interest rate. So just be careful with that. Well, I hope that's helped sort out your simple and compound interest for now. Keep a lookout for the next video that is going to cover annuities.